could start interacting with whatever components you're defining in your application layout. So I think now it's time to test our application and see if it's working as expected. So to test an emulator, there's a run button to play and run it. That's basically the normally green play button, which you could find on different tools and IDEs. So you click on that, and the application, first, the emulator will be automatically start if you didn't start it yet. And Android Studio will automatically install your app on this emulator, so you don't have to do it on your own and build it. So once you click it, you can see this page is actually from an emulator. That was the original setup. So hello square word and the click button. After I clicked on it, you can see on the top image that the text was changed to button click. So yep, that's it for the Wear OS development. We covered basically the main concepts that you need to start working with it. If you have some questions, of course, we'll leave them till the end for the Q&A. Now we'll be starting with WatchOS development. So WatchOS is Apple's proprietary OS for their watches. So unlike Wear OS, it only runs on Apple watches, so you can't run it on different devices. It basically comes pre-installed on all the watches by Apple. Currently, the latest version of WatchOS is WatchOS 10. It was announced on September this year, and it support the Apple Watches starting Series 4 till the latest ones, which were announced very recently, Apple Watch Series 9 and Apple Watch Ultra 2. So in this presentation, first, as we did with Android and basically Wear OS, we'll be covering the tools that you need to develop for Apple Watches or specifically WatchOS platform. So to do that, you'll be needing an Xcode starting version 3.1 or later. One thing about Xcode, so unlike Android Studio, which we covered that you could install on Windows, Linux, and macOS, Xcode can be only installed on macOS, so it's not supported for other PCs. So this might be a limitation if you want to develop an app for watches. Another thing about the platform and the language we'll be using for developing WatchOS app. So SwiftUI is basically the framework that's currently used. There were older frameworks previously, but currently SwiftUI is the one supported and recommended by Apple to develop apps, whether for your WatchOS or even their apps on their iPhones, etc. So SwiftUI, as you can tell from the name, is basically based on the Swift language. For this demo and presentation, you don't need to know a lot about Swift, but you can follow up easily and just understand the main concepts to get you started and with your first app development journey. So likewise, as we did with Android Studio, we're gonna create our new WatchOS app. So to start with it, you go into Xcode and select that you want to create a new project, as well as gonna prompt you to enter the platform you're developing for. So in our case, we're developing for WatchOS, and we're selecting what we want to develop, which is basically an app. So after you click on it, you'll be prompted into next screen. On the next screen, you'll be have the option to name your app and whether you want to create a companion app with it. So companion app, simply put, is an app that runs on your phone as well that can let your watch communicate with your phone. I'll be talking a little bit about it towards the end, but no need for that. So for this demo, we're just creating an app that runs only on the WatchOS. So we named our application, etc. Now it's time to configure an emulator. So to configure an emulator, usually there's a device manager by Xcode that's on the top of your screen. If you click on it, you'll be prompted to choose the iPhone. You need it even if you're developing for Wear OS. So you select an emulator phone, you click on it, and after that, you'd have a list of the paired watches by default it's empty. So you're gonna want to add a new one. So if you click here on the add sign, you'll be able to pair a new watch to your device. So you could call the emulator whatever you want. You could select the device type. So here we're selecting Apple Watch Series 4 and the OS version. That would be it to set up an emulator. And similar to Android Studio, the Xcode will take it from there. So you don't need to worry about managing this emulator on anything like that. So now we have our project ready, our emulator ready. I think we could start by developing for that platform. So the main concepts. So kind of similar to Android Studio, we have two main files, however, their functions differ. So you can see we have simple app. Simple is coming because I named my app simple. So this file is basically have as prefix whatever you name your application. And you have the content view, which comes by default. One thing you might notice that this is currently the structure of the latest 50R version. So if you're using a different framework or maybe an older version of SwiftUI, you might find different files. But since we're basically covering the newest, what's available and what's currently recommended by Apple, we went with the latest version of SwiftUI. So the simple app structure conforms to the app protocol, which is defined by Apple, SwiftUI SDK, and it contains the content of your application and behavior. So it has multiple scenes, and for each scene, there's some content. All of this, which are managed and controlled by the simple app file. And the content view, it's kind of similar to the activity main of Android Studio. The only so it's used to define your interface, your components, etc. However, one thing is that the interaction of these components and how you could interact with them, like a button on click on it, will also be done in this file. So both of our files are Swift files, so you can write code into them. So yeah, now in the next slides, I'll be talking more about each type of file and what it will be used for with a brief example. Uh, Once you create your application, if you create it as we did, it already comes pre-filled with some default values, which we won't touch for the sake of our application, but let us at least go into them and what you need. So first, you can see we're importing SwiftUI at the top. You need to import it to enable all the functionalities enabled by the framework. Next, you want to say set a main entry to your application. This is done through the main attribute that you can set over your application. One thing to note that one app, one file can only contain one entry point. So if you define two main entry points, your application won't compile or build. You can see, so we have our main attribute. Now we want to define our app structure. As you are saying, this file conforms to the app protocol. So we're going to create an app. Uh, as part of the app protocol, you need to define the body of your application, which contains a group of scenes. So in this example, we have only one group, which is a Windows group. You could add other groups for the settings which have different views. But here we have only one group, which is a Windows group, and it has the content view I was talking about. So now we linked our application to the content view through one of our available scenes here. Now, I think it's time we could go into the content view to look into it. One thing that to note that you don't need the default content view that is initialized to start with it. You could create your own views depending on the needs on your application. And probably if you're creating a big app, that's what you're trying to do. You won't be using the default one unless for small scoped applications, for example, in college or like. But if you're going with an application to production, you're going to be having different scenes, different content views, and they might be even interacting with each other differently. So that's it about the app file. Now for the content view, so it has a body just like we had a body for the app view. However, the body's type here is actually a view. Um, Similar to Android Studio, where we had a linear layout, which was vertical and it had other components. You can see here in our code, we have something similar. So we have a VStack, which is also some kind of a linear layout, and it has two components. So we have an image here, and we have a text. And the image is a system icon called the globe. You can see the icon here, it's visible. You have a text that just says hello world. You can edit this content view and see the changes in real time on a separate view of how your application is gonna look like. So you don't need to run your application or compile it to be able to design how it looks. You only need to run it for the functionality in case you added one. So as I was saying, the content view contains the SwiftUI provided view, which is VStack, and by default, it organizes and arranges the subviews vertically. We have two subviews in our application, which are an image and the text. Now we have our application ready. We didn't add some logic here. Uh, since I thought that it might be kind of a learning curve to learn Swift, but I think this is very self-explanatory. So we have the image and the text, and it's time to run it on a real device. So you'd also have a run button to do it. This run button would first compile your application and build it. If there are no compilation errors, it will start automatically on an emulator. If there are compilation errors, however, it would indicate them and ask you to fix it. So once you fix it again, you need to rebuild it to even have your app running. So this is an emulator. It's WatchOS Series 8, as you can see. Um, this is our layout. Our application is running fine after it succeeded. So the emulator will be run in a separate window in Xcode. You'll be able to interact with it directly. That's it for, I think, the WatchOS platform. Now we'll be talking about Fitbit OS development, which is the final OS in our presentation for today. So for the supported devices, so Fitbit OS is Fitbit's proprietary OS. So just like the Apple Watch, it can only run on Fitbit devices. Even more, so yeah, currently, the Fitbit OS 5.0, which is the latest one, can exclusively run on two Fitbit models, which are the Versa 3 and the Sense. One thing to note that Fitbit has been recently developing devices and watches that can be run on Wear OS. But since many of their watches come with Fitbit OS, we're gonna explore how to develop for Fitbit OS itself, since we already covered for Wear OS. And if you want to develop an app for a Fitbit watch that's running on Wear OS, the process would be very similar to what we discussed earlier in the application. However, currently we're just exclusively talking about Fitbit OS development. So I was saying that Fitbit OS 5 runs on two Fitbit models currently, which is the Fitbit Sense and Fitbit Versa 3. However, if you'd like to develop for older applications, they come with an older Fitbit OS, which is fine, and you could develop perfectly fine for them. Other watches include like the Versa 2, for example, Versa Lite, and etc. So for the development tools, so earlier when personally I started developing for Fitbit, there was a tool on the cloud which was called Fitbit Studio. It was provided by Fitbit themselves to help you develop apps for them. So it was a user interface. It automatically creates your project and you could see the files. So it was like an online IDE, and even it can be connected to an emulator downloaded to your device. So after you build your application, you can click on it and it would automatically open. However, recently, very recently actually, Fitbit decided to shut down the Fitbit Studio. And honestly, I just know about that when I was presenting for this application. So the change is very recent. However, it's important and has been asked by many developers. So to develop app nowadays for Fitbit Studio, you need a command line interface. You could install it using Node.js. So version 14 is the recommended version. You could install it with npx. I think there is an example how you could do that. Um, just like Wear OS, you could develop on different PCs types. So you could do it on Windows, Mac OS, or Linux. One thing to note for your own example why Fitbit pushed for that and what developers were asking for it instead of basically a nice UI you could find on the web, which you might think that it's more practical. However, for larger application, this was causing an issue since developers usually wants to use versioning tools like Git and basically collaborate on the same application on GitHub or Bitbucket, for example. This was very hard to do with Fitbit Studio because the applications are hosted on a UI on the web. So it was hard to version your application and connect to it directly and even collaborate with others. So now with the command line interface, your code would live in a Git repository, for example, and you could manage it as you see and it's actually very useful to say. I won't say that the Fitbit Studio was providing any addition to what's currently available. In fact, the command line interface is more powerful. However, you need to know the basic commands to interact with it, which is, I think, fine of the development. I'm not sure if any of you have tried previously Fitbit development, but yeah, that's the recent change. So one last thing. So we were saying about how to install an emulator for the devices. So for Wear OS, it came built in with um, Android Studio. For WatchOS, it came built in with Xcode. But since in Fitbit OS, and for Fitbit SDK development, we don't have our own IDE. So you could actually use your own IDE, and that's a pro of not being constrained by using Fitbit Studio. So you install whatever editor or IDE you could like. You could even use VS Code. You need to download a separate app for the Fitbit OS simulator, and it's available on the platform. So it's available on Windows, Mac OS, and Linux. So to get started, it's very simple. As I was saying, you need to have Node.js. Recommended version is 14 to create your app. So open your terminal or your command line tool and go into an empty application, empty folder. Create a folder for your application if you'd like so, and run this command. So npx create Fitbit app, and you could name your application whatever you'd like. Here we name it My First Clock. So it will take some time. So it will be downloading and installing some dependencies. And at the end, you can see here, it will be prompting you to select the type of our application you want to do. So I could just create a simple clock face, which has limited functionality, or you could create a full-fledged which has a wide range of functionalities. It has buttons, you could interact with the web, etc. So we'll be selecting an just like that. So after selecting this option, the command line tool will set up our application for us. So it will take some time. After that, you'll be opening it in your favorite IDE or text editor. So here I opened it in VS Code. Some of you might be able to see that this layer is familiar. So we also here see two main files. So it's kind of a trend where you have two main files, but it also makes sense. So there's a file to set your layout, to see what components you want. And there's an app a file, I mean, to control this layout. Likewise here, we have the same for Fitbit OS. So you'll see index.view file, which is used to set the layout of your application. To set the layout of your application, it's done through SVG. However, there are components available through Fitbit SDK. So if you go into the documentation, you'll find a large list of all the layouts and components available that you can just copy and paste into your code. In case you need to edit the functionality, of course, you'd be able to do that. Next, we have this small file I'll be talking about, which is styles.css, which is used to style your application. So just like CSS is used to style web application on the web, it can be used exactly for the same behavior to style your components that you created in the index view. And that's for the file in the resources folder. Then we'd go into our app, which is the index.js. Index.js is where the logic inside your app resides and how you could control application. You could dynamically decide to show one or more components, and you can switch the components appearing on the screen as you see fit. So it's in JavaScript, specifically in Node.js. However, one thing to note that is not everything in Node.js is available in this. So you need to confine with Fitbit OS SDK that have their own SDK that's based on Node.js. Um, you can find everything about it in their documentation. You can tell you everything you need to interact with your application, including connected with the internet. So in the internet, that's one example where there's a difference between Fitbit SDK and Node.js. So in Node.js, if you want to create an HTTP request to directly talk to a web server that you have, there's built-in tools which could use directly. You set whether you want a post or a GET request. You set the URI, and you get back the response easily. However, to be able to do it in Fitbit SDK, it's not currently supported directly. This is actually for a reason, since the watch have limited capabilities connected to the internet. So if you actually want to do that, you need to create a separate app called the companion app, which has its own index.js file. And you're gonna be needing to send this request to your phone. So your phone will be able to understand from the watch that it wants to connect to the internet. And then also Fitbit provides an SDK to develop the companion app on the phone. It will talk to the internet, get the data that you want, and get it back to the watch. As you can see, so these are the differences you might encounter between Node.js or Fitbit SDK. However, the syntax is very similar since the Fitbit SDK is based on Node.js, I was saying. Two main things to note that you could, for example, come here and delete the styles.css. You might not want to style your layout. However, it is mandatory to have an index.view and index.js application. Even if you want to design just a clock face without any functionality, you need to have index.js set up if you selected that you want to create an app for Fitbit. That would be it for the Fitbit OS introduction. So for the take of the time, we won't be covering an example. However, it's very similar to the previous ones. To run your application, you could have commands uh, from the Fitbit command line tool to build and run your application, which you can find on the official documentation. Now, as a general concept, so we did cover how to develop app for three different OS, and you can see that each one of them is different. They have different set of tools. You need to have different environments to run of them. For example, WatchOS, you need macOS to be run on it. And even each one of them uses different tools. So to develop for Wear OS, you need to know Java or Kotlin. To develop for WatchOS, you need to know the Swift language. And to develop for Fitbit, you need to know JavaScript. However, Although there are much differences, there are mainly general concepts which are shared among all of these watches, and they're not necessarily technical. So just main ideas and concepts that you should apply whether you're developing on any of the other platforms. So one thing you note, which I mentioned briefly in my application, that all these apps that are running on watches can communicate with a paired phone to do more advanced operations. So for Fitbit, if you wanted to connect to the internet and send an HTTP request, this is considered an advanced operation and you need a paired phone. All these platforms support that by default, so you don't have to manually configure a lot of stuff. You just select that you want to create an app with a companion phone app. This is what usually what it's called. And you'd have basically two projects, two sub-projects, one for your regular application and one for your phone application. And it will just act and communicate with each other as needed. Also, as you know, so watches on all platforms come with different sensors. So there are sensors to connect with your heart rate, get access to your steps count. Some of them are even advanced that can communicate, can get blood pressure, or even do a scan on your body. Um, so yeah, they come with different sensors, and your application should make use of these sensors. Usually, if you're creating a fitness tracking app, you'll be using these sensors and interacting with them a lot. However, since this information captured by the sensors are very personal, so they should be and private. In your application, you need to ask the user's permission to be able to use whatever data you'd like in your app. So you can't just access the steps count on the user if they installed your app. So you need to prompt them to give you permission to use this data and to use this data inside your app and basically enable whatever functionality you'll be aiming for. And it's very simple to do. It's also supported built in the platform, so you don't need to create anything new for that matter. It can be found by simple Google search, if you'd like to say. So that's it for the common features. One thing I'd want to add, which is not found on the slide, so it's about the design. So when designing an app for the watches, keep in mind that the user have limited screen space area. So it's recommended not to add too many components. So on the same screen, you shouldn't have like two or three buttons and different text views and the table or I don't know what. It's a general practice and recommended to have as many as minimal components as possible since it's easier for the user to interact with the app. We have just two items to click on it, and this is common for all watches. And you can find it even as a recommendation uh, in the official documentation of all three platforms. So by theory, you could get an Android application, and it should run perfectly fine on a watch OS if it does the main stuff like interacting with components and so. Since you also need Android Studio and you could run it with Java, Android Studio would handle everything for you and install it directly on the watch. However, it's not a good practice to do so since the screen area of a phone is much different than that of a watch. So hence it will gonna have much more components that will be complicated, not a good experience to show if you're trying to do it on a smaller screen, which is a watch, for example. Also, you need to note something which might not very big an issue, but the shape of the watch itself. So it might come in rounded shape or square shape. Currently, on different platforms, it can come with different shapes. So Wear OS, since they are developed with multiple manufacturers, manufacturers can come with their own design. So you'd find that for the Apple Watches, currently all the Apple Watches are square design. The only difference is basically with the screen size, which shouldn't affect much how you're developing app. And for Fitbit, They can come in rounded shape, square shape, or even they have this vertical shape, which has very, very minimal screen area that has their own considerations if you're trying to develop an app for it. So yeah, that's it for our presentation, and I'll be opening the room for Q&A. Thank you, everyone. So, any questions?
Khalid, question available in chat box.
Oh, okay, I see. Okay, so Yasser was asking what's the use of Gradle scripts. So Gradle scripts are used as a build tool for your application. So as you know, each application, you need to build it and run it. So you have a Java app, but you need to compile it. And there's where Gradle scripts come into place. They're the supported one by default by Android Studio to build your application. Did I answer your question? Okay, so Yasser was also asking about UIKit storyboard for for WatchOS, I think you meant. So yes, it is. However, it's not the recent one. So currently the one recommended is SwiftUI. However, if you want to go with UIKit, the file structure and even the way you're developing the application would be fundamentally different to what I showed you today. It's perfectly possible. However, if you're still trying to learn it in you and you don't have experience knowledge with UIKit, I recommend you to start with SwiftUI. So is it possible to develop wearable apps through hybrid stacks? So for the wearables, no. You can see that you could actually do it for phone applications, but as of now, it's not supported. So not to my knowledge, at least on the recent knowledge on React Native and Flutter, both of them do not support that. You can make sure of that, but uh, based on the latest news, I don't think you could actually do that. They just support app development on multiple platforms. One thing to note that even if they were to be supported, the different system that you need, for example, to develop for watchOS, you need a macOS. You still be needing macOS to develop and run your application, even if you're using React Native or Flutter. So you'd be able to develop your app, but you cannot build it unless it's running on macOS. This is currently how it is on the applications for the phone. So I assume it'd be very similar if we were to be added uh, to have the same behavior. So we have another question. In the market, more number of wearables are there. My doubt is, do everything have the same OS or different OS? If different OS, please share what are the OS for different devices. So yeah, as we were covering on application, and as you were saying, so in the market, you have different watches and by different manufacturers. So usually each one of them have their own operating system. And we saw in our application, we developed for Wear OS, for WatchOS, and for Fitbit OS. These are three of the most popular operating systems. However, you could even find more of them. So the ones we discussed are some examples, and they're basically the most popular ones. Most watches you come across, they'll be, if they're not actually an Apple Watch or a Fitbit Watch, they're gonna be running on Wear OS. However, recently Huawei have their own operating system for watches as well. So we have, did I answer your question? If not, we can come back later. But now I'm checking a question, which is how to use SDK and wearable devices. So SDK, if you'd like to say, is the library that provides you the methods to interact with your app. So it's the code that you write. So if you recall in the Android application, we had a button and it had an on-click listener. On that on-click listener is supported by the Android SDK. So in normal Java, if you have creating a normal Java application, you don't have the button type, or you won't have the set on create listener. But since you're using an Android SDK, it is giving you access to all these extra methods and components like buttons, text view that you could use in your code. So yeah, that's basically what uh, what an SDK is. Wearable devices can be hackable. Yes, so each tool comes with its own vulnerabilities. Uh, to make it basically against some security attacks, two things are supported. You can make sure that your app is secure enough, which is by following the right practices that are found on Google's SDK. However, sometimes the operating system you're running on can have some vulnerabilities and can be hacked on. This you don't have to be worrying about. So if you're on Wear OS, Google will be pushing security updates on the operating system to catch these vulnerabilities. One thing to note that it's not easy to hack these devices, but it is possible. So if you're trying to create a big app, you're gonna want it to go on production, you should make sure that you have some security checks on that. So we have another question. So what's the difference between native and hybrid app development? So native app development uses the SDKs recommended by each platform to develop the apps using their own tools, their own framework. So for example, native development, if you want to create an Android application or Wear OS application, you need to be using Android Studio with Kotlin or Java, and you need to build it using the Android SDK directly and write your code in this one. And if you want to create a similar application with the same functionality on a different device, on different operating system, I'll be giving the example here of phone development since hybrid isn't currently supported on watches. So if you want to create the same application, the same functionality on an iPhone, you would need to use different language, which is Swift, different framework with Swift UI, using Xcode, and write the same code that does the same thing on two devices differently. And if you want to add a new functionality, you'd be have to adding it in two places. For hybrid app development, its uses is that you can use the same platform, the same framework, and write only one code that can be run on applications for different operating systems. You might say that that's a great idea. I'd always want to do it. Why do I want to create separate apps, separate codes for an app if I want it to be on different devices? That is a valid point, and that's an advantage of using hybrid app development. However, sometimes and usually actually, if native apps are more fluid since they interact natively by the OS directly, so they have better user experience overall since they are optimized whether by Google or Apple to run as smooth as possible on the app. So do we still have time to go over the rest of the questions? There are three more questions in the chat.
Madam, can we go for a few more minutes to answer the question?
Yes, sir. You can, sir.
Please go ahead.
Okay, thank you. So yeah, we're still, what are the sensors used in wearable devices? So usually different devices have different sensors. There are the general sensor that comes and you rarely interact with, which are like the gyroscope sensor, uh, the GPS sensor. These are common to the Apple Watches. For example, the gyroscope sensor can be used to see which layout you're using your device with, and it can detect, for example, crashes. So some operating system or watches have some emergency tools, whether there's a crash or like that. So in addition to the microphone, which is a sensor, they can also use a gyroscope sensor to detect that, for example, your watch fall. And other than that, there are multiple health related sensors So there are sensors to detect your movement, hence your steps count. There are sensors to detect your heart rate. It's used when basically when you're working out, it can warn you if your heart rate exceeded a specific limit that's dangerous. There are recently some sensors to clear blood pressure, which is actually very hard to do. They're not very accurate, but there are some operating system, not operating system, basically watches from manufacturers that have this supported. Some of them have body composition tests to see like how much muscles, fat you have in your body. They also come as well. One thing to note that specifically for the health sensors, they're not very accurate, so they cannot be used for medical purposes. It's just for tracking health and very minor, so they cannot replace medical devices. That's what I'm trying to say. Why cannot be removed index.js and index.view? This constraint is set by the Fitbit SDK themselves. So if you remove them and you attempted to build the application, it won't be able to run since Fitbit prohibits that. So why do they prohibit that? It kind of makes sense. So if you want to create an application, you need a layout. So you need to see what components you have, and you need to control that layout. And these two files control this behavior. Hence, why we would not want to remove them. So in the Wear OS application available on Play Store or App Store, or just embedded on the devices only. So for Wear OS application, they do come. So each watch come with its own store, so where you can install extra apps. Once you get the watch itself, it can come with preloaded apps, which are for the general needs. So apps to do phone calls, maybe to even there are some apps that do health tracking, etc. But if you want application that does extra stuff, you'll find it on the Play Store. So the app, you also find App Store for the basically applications on the WatchOS platform. So each platform have their own market store where you can install extra apps onto it. Usually you might not need to do that. The default set of application is actually really nice, unlike the phone where you have to install multiple apps to use it. Usually WatchOS come with the applications you're going to be using mostly in your day-to-day. So yeah, that's it for the questions. I think no more questions.
Sir, Hajira ma'am raised her hands.
How do we advise on the hand you were saying? Can you repeat the question?
Hajira ma'am, you can ask your question, ma'am.
Okay, yes. No questions?
Or you may type the question in chat box, ma'am.
Yes, that would be good also.
Okay. Okay, sir. I think no more questions.
Yeah. So yeah, thank you everyone for having me today, and I hope that you benefited as much as possible from this 1 hour. So yeah, please share your feedback in the forum shared. You can always ask me and connect with me later, so you can find me on LinkedIn, Khaled Baghdad. This is my name. You can see on Google Meets if you have further question about this topic. Thank you, everyone. So I think I'll be handing it to Mr. Krishna.
Thank you, Khaled. I think that's wonderful. Again, one of the reasons when Deepti Lakshmi Madam asked us to come up with a topic for the FDP, wearables are going to be very, very important. I think one of the recent trends in the technology is wearables, and especially smartwatches. I think Khaled touched upon. Not only you need the watch to find out what time it is, but just like how people use smartphone just for just for calling, there are so many other things that they use it for. Wearable smartwatches are getting used for tracking your steps, some other health benefits as well. Though they are not 100% accurate, but I think they're getting there. Technology is getting better. In fact, India is the largest consumer of smartwatches. I think they recently crossed, and we have become the #1 country in the world to consume the smartwatches. So I thought that it would be beneficial for students from India to learn about what are the various platforms available. I think Khalid covered from Android, from Google, it is Wear OS, from Apple, it is WatchOS. Fitbit, by the way, is also bought by Google. There's a reason why Fitbit starting to support Android or Wear OS and Java and so on. So I thought that was a great presentation. Thanks, Khalid, for your wonderful work. So appreciate the time in preparing the material and sharing that. And once again, I want to thank Deepa Lakshmi Madam for giving us an opportunity to present these type of seminars and an opportunity to share the information that could be relevant for our students and staff. So over to you, Madam, for any concluding remarks.
So shall we wind up with the formal vote of thanks, sir?
Sure, Madam.
Okay.
Thank you, sir. Next, I welcome Mrs. S. Deepa Lakshmi ma'am, Head and Assistant Professor of PG Department of Computer Science, to propose the vote of thanks.
Good morning, everyone. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to the Almighty God for making today's occasion a resounding success. First and foremost, I thank our chief guest, Mr. Khalid Baghdadi, and software development consultant, Acrio, who, despite his busy schedule, found time to grace this occasion. And also express my heartfelt thanks to Dr. Krishna Kumar sir, founder, softwareinterns.com, and Vice President of Engineering, Acrio team, and the Software Interns team for his valuable contribution and support throughout all the 5 days. We are grateful to our Secretary, sir, for his word of encouragement. His able guidance has always encouraged us. I thank our principal and coordinator, Self-Finance, for their kindness, interest, and their continued support. My heartfelt thanks to the faculty of our college and also other colleges for their valuable presence throughout all the 5 days. My special gratitude to the non-teaching staff who has worked hard to ensure this occasion become a memorable success. At last, I thank our student friends for their dedicated contribution for this program. Thank you one and all, and thank you, sir, and thank you, Khalid, for a wonderful presentation. Thank you, sir.
Thank you, everyone. And thanks
Thank
for
you
this
all.
opportunity.
Very interactive one also.
Yes, I really enjoyed the questions. So I like that everyone was asking questions and they seemed interested and invested in the topic.
Sir, we just get awareness from you, sir. We have a lot of doubts. So once we get some knowledge from wearables, then I will contact you for the doubts, sir.
Sure. Yeah, you
Just
can
to
always
know the
find.
basics.
Yeah, hey, Mr. Krishna, you could share my contacts. Whether I also send LinkedIn, so if anyone wants to reach out for me later, I'll be more than happy to help.
Okay, sir. Sir, please share your PPT for sharing your PPT to the other college staff members, sir. So they need a presentation, sir.
Sure. Mr. Krishna, you're muted. I think we cannot hear you.
Yeah,
Sorry.
so I was going to say, sorry, I was on mute and talking. Yeah, so Madam, I will send Khalid's presentation to our WhatsApp group. You can take it from there, Madam.
Okay, sir. Thank you. Thank you. Thank you for the motivation and support, sir.
Excellent. Thank you. Thank you all. Appreciate it. Bye now. We'll
Bye,
sign off.
sir.
Bye.
Bye.
Shall we
Have
wind
a
up?
good one.